Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter circular motion. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comment section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told a vehicle of mass 200 kg is moving along a leveled road, a level curved road. It is moving along a level curved road of radius 70 meter angular velocity with angular velocity of 0.2 radian per second. The centripetal force acting on the vehicle is. So the centripetal force we have to find. Centripetal force is given as m omega square r. So this will be m, that is 200 kg, and omega is 0.2 whole square into r is 70. So this much Newton. This will be 200 into 70 into 0.2, so it is 0.04. So this will be 2 by 100. So 2 into 100, so 100 into 4 by 100. So this will be 4. Go to the 8 into 70, that is 7, it is a 560 Newton. So 560 Newton is the centripetal force. Option A is the correct answer. Then it is told a coin placed on a rotating table. There is a rotating table. So it can rotate about its axis. So one coin is placed at a distance of 1 centimeter from the center. So this is r equals to 1 centimeter, means it is 0.01 meter. So at a distance of 0.01 meter, the coin is placed from the center. If the angular velocity of the table is halved, okay, so it is told a coin placed on a rotating table just slips. So here it will just slip. So if so it means here some friction is acting. Let's say the coefficient of friction is mu. And if the angular velocity is halved, it will just slip when placed at a distance of dash from the center. So here actually the normal reaction is mg, and the friction, that is mu n, that is equal to m omega square r. So here mu n is equal to mg, mu mg equal to m omega square r. So therefore r will be equal to m will cancel, that is mu g by omega square. So it means now mu and g will be constant. This part will be constant. So therefore I can say the radius means the distance from the center at which the coin will just slip, that is inversely proportional to omega square. So now if omega is reduced to half, then the radius will increase to 4 times. Since by omega by 2 whole square, if 1 by 2 omega by 2 whole square if you do, then it will come 4 by omega square. So it means that the radius will be increased to 4 times. It means here when the angular velocity is omega, then it just slips at 1 centimeter away from the center. So now it will slip at a distance of 4 centimeter away from the center. So option C is the correct answer. And here it is told, as shown in the figure, a particle is moving with a constant speed pi meter per second. Considering its motion from A to B, the magnitude of the average velocity is magnitude of the average velocity is. So now average velocity, that is given as the total displacement by time. Total displacement divided by time. Now time required to go from A to B, that will be equal to the arc length from A to B, AB arc length divided by the speed, that is V. V is constant. And AB arc length, that will be equal to R into theta, and theta should be used in radians. So 120 into pi by 180. So this will be 6 to 12, 6 is 18. So this is 2 pi r by 3. This will be 2 pi r by 3 divided by V. V is pi. So pi will cancel. So this is 2 r by 3 seconds. So the time required is 2 r by 3 seconds, and the displacement will be equal to, from here to here, the distance from A to B that we have to find out. The distance from A to B. So this length, that will be equal to, this is the radius, this is 60 degree. Now if we draw one perpendicular, we draw one uh, perpendicular on this chord AB from the center, that will obviously bisect the chord. So if the length of AB is, suppose x, arc length AB is x, no, the AB, the chord length, chord AB, that is equal to x units, suppose, then this will be x by 2, this will be x by 2. So now this will be 60 degree. So therefore you can say that r cos theta, sorry, r sin 60, that will be equal to x by 2. Therefore x will be equal to 2r sin 60, 2r into root 3 by 2. That will, so x will be equal to r root 3. Therefore the displacement, that is same as the length of the chord AB. Chord AB length, that is r root 3. So therefore the average velocity, that will be equal to the displacement, that is r root 3, divided by the time, that is 2r by 3. Time, that is 2r by 3. So r and r will get cancelled. So it will come 3 root 3 by 2 meter per second. 3 root 3 by 2 meter per second, or we can say this will be 1.5 root 3 meter per second. So option B is the correct answer. Then here it is told a child of mass 5 kg is going around a merry-go-round that makes one rotation in 3.14 seconds. The radius of the merry-go-round is 2 meters. The centrifugal force on the child will be. So the child is going on a merry-go-round, and its mass is, weight is acting downwards, mg, mass is 5 kg, and one rotation is made. One rotation one rotation is made in pi seconds. So therefore, the time period is pi seconds. The radius of the merry-go-round radius is 2 meters. Then the centrifugal force on the child will be, the centrifugal force that will be m omega square r. Centrifugal force that will be m omega square r. So m, so I can say m into, this is 2 pi by t whole square into r. Now mass is 5 kg. 5 into radius is 2 meter, and this is 4 pi square divided by t square. T is also pi, so it is pi square. So this much Newton. So pi square will cancel. So this is 40 Newton. So 40 Newton will be the centrifugal force that is acting on the child. Option D is the correct answer. Then here it is told a particle is moving with a constant speed in a circular path. A particle is moving with a constant speed in a circular path when the particle turns by an angle 90 degree. When it turns by an angle 90 degree, then the ratio of instantaneous velocity to its average velocity is pi is to root 2x. Pi is to x root 2. The value of x will be. So now here the instantaneous velocity will be v only, which is the constant speed, and average velocity that will be equal to the total displacement by time. Total displacement divided by time. So the displacement that will be, this is r, then the displacement will be r root 2. So displacement is r root 2 divided by time. So time will be time. Okay. The time taken to go from this point A to the point B. So that will be, so this is 1/4 rotation. So this is 1/4 of the 1/4 of the time period. So this is 1/4 of the time period, that is 2 pi r by v. So this is 2 to the 4. So this is pi r by 2v. So v average that will be the time. This is pi r by 2v. So r will cancel. So this is coming 2 root 2 v by pi. 2 root 2 v by pi. So now therefore the ratio of the instantaneous velocity is to the average velocity. So that will be equal to, the instantaneous velocity will be v and average velocity will be 2 root 2 v by pi. So v and v will cancel. This will come pi is to 2 root 2. So it means x will be equal to 2. So option D is the correct answer. Then here it is told a small block of mass 100 gram is tied to a spring of spring constant. A small block okay, so here we have a spring. So a small block is tied of mass m, which is 0.1 kg. It is tied to a spring of spring constant, that is 7.5 Newton per meter, and the length of the spring, that is 20 centimeter. The other end of the spring is fixed to a particular point A. If the block moves in a circular path, the block moves in a circular path on a smooth horizontal surface. So it is the horizontal plane. It is not the vertical plane. is the horizontal plane. Okay. So if the block moves in a circular path on a smooth horizontal surface, so it is smooth only with constant angular velocity 5 radian per second. So it is moving with an angular velocity 5 radian per second about the point A, then the tension in the spring is. So how much will be the tension in the spring? So that tension in the spring, that will be equal to kx, where x is the extension in the spring. So here only the tension force is acting towards the center, and normal reaction upwards and mg downwards, these are not the forces towards the center. These forces are not acting towards the center, so these forces will not contribute to the centripetal force. So the tension force, that is kx, that is only equal to the centripetal force. So kx, so this tension force only you have to find, is equal to m omega square into L. M omega square L. Therefore, the tension force will be M. There is here actually the actual length was L, but after extension, the length will be L plus X. So therefore, we can say Kx, that will be equal to M omega square into L plus X. So from here we can find out X actually. So Kx by M omega square, that will be equal to L plus X. So X into K by omega square minus 1, K by M omega square minus 1, that will be equal to L. So X will be equal to L by K by M omega square minus 1. Therefore, X will be equal to L. L is 20 centimeters, so 0.2 me meter. 0.2 meter is the length, divided by K. K is 7.5 divided by M omega square. M is 100 gram, that is 0.1 kg, and omega, that is 5 radian per second. So omega square, that will be 25, which is 7.5 minus 1. So therefore x will be equal to 0.2 divided by, this is 2.5. So 25, 3 is 75, 3 minus 1, that is 2. So x will be equal to 0.1 meter. So therefore the tension force, that will be equal to kx. So k is equal to 7.5 into 0.1, that is 0.75 Newton. 0.75 Newton is the tension force in the spring. So option C is the correct answer. Then here it is told a stone of mass 1 kg is tied to the end of a massless string of length 1 meter. If the breaking tension of the string is 400 Newton, then maximum linear velocity the stone can have without breaking the string while rotating in a horizontal plane. So suppose the stone, it is rotating in a horizontal plane. It is rotating in a horizontal plane, and the mass is 1 kg, and the length of the string, that is 1 meter, and the breaking tension of the string, breaking tension is 400 Newton. Then the maximum linear velocity the stone can have without breaking the string while rotating in the horizontal plane is the maximum linear velocity that the stone can have without breaking the string while rotating in the horizontal plane. So the tension that provides the necessary centripetal force, that is equal to mv square by r, where r is equal to L here. So T will be equal to mv square by L. So this V has been asked, the maximum linear velocity that the string, that the stone can have. So V square, that will be equal to TL by M, TL by M. So V maximum, that will be equal to TL by M. So therefore, the linear speed, that will be root over the tension, that is 400 into L, that is 1 meter, divided by mass, that is 1 kg. So that will be 20 meter per second. So option A is the correct answer. Then here it is told a body is moving with constant speed in a circle of radius 10 meter. The body completes one revolution in 4 seconds. A body is moving with a constant speed in a circle of radius 10 meter. The body completes one revolution in 4 seconds. So it means the time period is 4 seconds. At the end of the third second, the displacement of the body from its starting point. So you have to find the displacement of the body from its starting point. So it will reach somewhere here, since it will complete 3/4 rotation. Since why 3 seconds means it is 3t by 4. 3t by 4. It means that it is 3/4 revolution. 3/4 revolution is completed. So it means that it will reach somewhere here. Then we have to find the displacement of the body from its starting point. This length AB that we have to find out. So for the radius of the circle is r, that is 10 meters. So this will be also r, and this will be r root 2. So therefore the displacement of the object, that will be equal to 10 root 2 meters. 10 root 2 meter is the required displacement. So option C is the correct answer. And here it is told that the object moves at a constant speed along a circular path in a horizontal plane with center at the origin. Center is at the origin, and it just moves at a constant speed v. V, that is constant. Then when the object is at x equal to plus 2, the object is at x equal to plus 2 meter, and its velocity is minus 4 j cap meter per second. The object's velocity v and acceleration at x equal to minus 2 meter will be. So it will reach here. Means the velocity will be towards the positive y-axis. Means the velocity will be 4 j cap meter per second. Since why it moves with a constant speed. The speed is constant. Means the magnitude of the velocity will be constant. And acceleration will be towards the center of, obviously. So towards the center, it means that it will be along I cap. It will be along the positive x-axis. So centripetal acceleration is v square by r, and here it will be v square by l. It will be v square by l. So v square, v is 4 square by l. L is 2 meters. So this will be 16 by 2, that is 8 meter per second square, and into I cap. So acceleration is 8 I cap meter per second square, and velocity is 4 j cap meter per second. So option B is the correct answer. And here it is told a car is moving on a horizontal curved road with radius 50 meter. It is moving on a horizontal curved road. Moving on a horizontal curved road of radius 50 meter. The approximate maximum speed of the car, will be, if friction in between tires and road is 0.34. So it means the coefficient of friction in between tires and the road is 0.34, and we have to take the value of g as 10 meter per second square. So now, therefore, we have to find approximate maximum speed of the car. Approximate maximum speed of the car. So now here friction is there, and then the friction will provide the necessary centripetal force, that is equal to m v square by r, and friction maximum value will be equal to mu mg, since why the normal reaction will be same as mg. So m will cancel, then we can say v will be equal to root over mu rg. So the maximum safe speed of the car, that should be square root of mu rg, and therefore the maximum safe speed, that is equal to square root of mu is 0.34 into r. R is 50. Actually r is 50 meter. R is 50 meter. Friction coefficient, that will be equal to 0.34. Okay, 0.34 into 50 into g. G is equal to 10. This will be equal to square root of 0.34 into this 500. So I can tell 1000 by 2. So this will be 2 1s are 2, 2 7s are 14. So root over 170. Root over 170 means it is approximately square root of 169, that is equal to 13. So it is 13.1 approx meter per second. So option B is the correct answer. Then here it is told a car is moving with a constant speed on a horizontal circular track of radius. Its radius is 40 meter, and it is moving with a constant speed 20 meter per second. A bob is suspended from the roof of the car by the massless spring. So from the roof of the car, a bob is suspended. So the angle made by the string with the vertical will be. So this angle will be theta. So this theta we have to find out. If the car is moving in a curved road with a speed v, so here if we go inside the frame of the car, then pseudo force will act. If mass of the bob is m, then the centrifugal force will act, which is the pseudo force, that is m v square by r. R is the radius of the curved road, and downwards mg will act. So if this is the tension force, then we can say this will be t cos theta, this will be t sin theta. So therefore t cos theta component, that should be equal to mg, and t sin theta component, that should be equal to mv square by r. So therefore if we divide these two, then we'll get tan theta, that will be equal to sin theta by cos theta, that will be equal to v square by rg. Tan theta equal to v square by rg. So therefore tan theta, that will be equal to v square, v into v, 20 into 20 by r. R is 40 into g. G is 10. So this will be equal to 0, 0 will cancel. So 4 on the 4. So tan theta equals to 1. So it means that angle theta will be equal to 45 degrees, or I can say pi by 4 radians. So pi by 4 radians, option C is the correct answer. Then here it is told that a body of mass 200 gram is tied to a spring of spring constant 12.5 Newton per meter, while the other end of the spring is fixed at a point O. If the body moves about point O in a circular path on a smooth horizontal surface, it moves on a smooth horizontal surface with constant angular speed, which is 5 radian per second, then the ratio of the extension in the spring to its natural length will be. Then the ratio of extension in the spring, so it is tied to a spring of spring constant K, that is 12.5 Newton per meter, and mass of the body, that is 0.2 kg, since it is 200 gram, and it is moving on a smooth horizontal surface. So smooth means there is no friction. No friction is there. The ratio of the extension in the spring, let's say the extension is x in the spring to its natural length L, that will be how much? So x by L, that is how much that we have to find out. It means x is to L, that we have to find out. X is the extension in the spring and L is the natural length of the spring. So now therefore here you can say that the tension force that is equal to kx, and that is equal to m omega square into L plus x. M omega square into L plus x. So therefore we can say kx will be equal to m omega square into L plus x. L plus x. So therefore if we divide both sides by x, then we will get k equal to m omega square into L by x plus 1. So therefore L by x plus 1, that is equal to k by m omega square. So for L by x, that will be equal to k by m omega square minus 1. Okay, so therefore L by x, that will be equal to K is 12.5. 12.5 by m is 0.2 into omega. Omega is 5. So 5 square, that is 25, into this will be, okay, k by m omega square minus 1. So for L by x, that is equal to, so this is 25, 5 is 125, this is 0.5. So 5 by 2, that is 2.5 minus 1. So this is 1.5. Means this is equal to 3 by 2. So therefore L by x, that is equal to 3 by 2. So therefore x by L, that will be equal to 2 by 3. Therefore x is to L, that will be equal to 2 is to 3. So therefore the required ratio of the extension of the spring to its natural length will be 2 is to 3. So option B is the correct answer. Then here it is told a stone is tied to 180 centimeter long string. The stone is tied to 180 centimeter long string. 180 centimeters, so we can say L will be equal to 1.8 meters, and is making 28 revolutions in a horizontal circle in every minute. So 28 revolutions in 1 minute means in 60 seconds. So therefore, one revolution will be made in 60 by 28 minutes. No, 60 by 28 seconds, which is 4 sevens are 28, 15 for the 60. So therefore, the time period, that will be 15 by 7 seconds. Time period is 15 by 7 seconds. And it is told that we have to take pi as 22 by 7. Then the magnitude of acceleration of the stone is, so acceleration of the stone, that is the centripetal acceleration, that is m omega square r, or m omega square, this will be L, m omega square L. Since why the radius of the circular path is same as the length of the string. Sorry, so it will be omega square L. So omega, that is 2 pi by t. So 2 into 22 by 7, 2 pi by t, that is 15 by 7. So 2 pi by t, that's whole square into L. L, that is 1.8. So this much we will get in meter per second square. So 7 will cancel out, and this will be 44 by 15, 44 by 15 whole square into 1.8 meter per second square. So therefore the time, that will be equal to 44 square, 44 into 44 by 15 into 15 into 1.8 seconds. And this, sorry, this is the acceleration, sorry. This is the acceleration of the stone. And this is equal to 1936 by x meter per second square. Then we have to find out x. So now therefore we can tell 44 into 44 by 15 into 15 into 1.8 into 18 by 10. This is equal to 1936 by x. Then we have to find out x. So this will be how much? This will be 3 5 the 15, 3 6 the 18, 3 5 the 15, 3 2 the 6, then 2 5 the 10. So this will be 44 into 44 divided by 125. And now that is equal to 1936 by x. Now 44 into 44. So 44 square, that is equal to, I can write 40 plus 4 whole square, that is equal to 1600 plus 4 plus 16 plus 2ab. 4 to the 16, 160 into 2, that is 320. So this will be 1936. So it is 44 square. So 44 square and 44 square, that will cancel out. So x will be equal to 125. So the value of x is 125. So here it is told that a smooth circular groove has a smooth vertical wall as shown in the figure. A block of mass m moves against the wall with a speed v. So it is moving with a speed v. Which of the following curve represents the correct relation in between correct in between the normal reaction on the block by the wall and the speed of the block v? So it means the normal reaction will act towards the center, and the normal reaction will only provide the necessary centripetal force, which is mv square by r. So therefore the normal reaction is proportional to v square. So the normal reaction is proportional to v square. So n versus v graph we have to draw. So here y is proportional to x square. So the graph will be a parabola. It will be like this. So n versus v square. N versus v graph will be like this, since y n is proportional to v square. So option A is the correct answer. Then here it is told a person moved from A to B on a circular path as shown in the figure. If the distance traveled by him is 60 meter, then the magnitude of displacement would be. So the distance traveled, that will be equal to the arc length AB, that is equal to 60 meter, and the arc length AB, that is equal to r into theta. Theta we have to find in radians, which is 135 into pi by 180, that is equal to 60 meter. Therefore we can say this will be 9 2s are 18, 0 0, 9 1s are 9, 5 9s are 45, and 5 3 are 15, 5 4s are 20. So this is r into 3 pi by 4, that is equal to 60. So therefore the radius, that will be equal to 60 into 4 by 3 pi. So that is 320. So it is 80 by pi meters. So 80 by pi meter is the radius. Now then the magnitude of the displacement we have to find. Magnitude of the displacement. So the displacement we have to find out, that is the chord length AB. The chord length AB we have to find. So if we draw one perpendicular to the chord, this will be x by 2, this will be x by 2. If AB length is x, and this will be, this length we can say is at this angle theta, this will be equal to 180 minus 35, 180 minus 135 divided by 2. It should be equal to 45 divided by 2. So this is 22.5 degrees. So x by 2, that is equal to 80 by pi cos theta. It's equal to 80 by pi cos 45 degree by 2. So x will be equal to 2 twice of this, 160 by pi cos 45 degree by 2. Therefore, x will be equal to 160 by pi cos 45 degree divided by 2. Now, so cos theta, we can say it is cos 2 theta is 2 cos square theta minus 1. So cos square theta, that is equal to 1 plus cos 2 theta by 2. Therefore, I can say cos square 45 degree divided by 2, that will be equal to 1 plus cos 45 degree divided by 2. So it is 1 plus 0.7 divided by 2, that is 1.7 by 2, which is 0.2, 8 is 16, 2 5 is 10. 8 is 16, 2 is 10. So cos 45 degree divided by 2, that is equal to a root over 0.85, that is approximately 0.9. Since y 0.9 square will be 0.81. So x will be equal to 160 degree divided by pi, that is 3.14 into 0.9 approximately. This approximately we can tell 3 is 9, 0.3. So this is 3 into 16, that is approximately 48. Approximately 48. So we can tell 47 meter approx. Here it is told cos 45 will be 0.7. Cos 135 is told minus 0.7. Now cos 135 means it is minus cos 45 degree, that is minus 0.7. So cos 45 is 0.7. So it will be approximately 48, or so the displacement will be 47. So option B is the correct answer. And here it is told a particle of mass m is moving in a circular path of constant radius r such that its centripetal acceleration a is varying with time as k square r t square. Now centripetal acceleration is given as omega square r. So therefore omega square r, that is equal to k square r t square. So therefore omega will be equal to kt. Omega equals to kt. So omega is varying with time. So therefore the velocity, that is r omega, that is equals to ktr. So therefore the actually the when it is moving in a circular path of constant radius, then the centripetal acceleration is acting towards the center, and the force, centripetal force is acting towards the center, and the velocity is acting tangentially. So the work done by the centripetal force, that will be equal to 0 only, since the angle in between them is 90 degrees. So now therefore work done by the tangential force, that is acting along the tangent only, so it will do the work. So ft into v, ft into uh, ft into ds. Now ds, that is equal to v dt. So therefore the power that is delivered to the particle by the force, delivered, that will be equal to ft into v. So the tangential force equal to mass into tangential acceleration, and tangential acceleration is dv by dt. dv by dt. So now from here dv by dt, that will be equal to k into r. So therefore the power delivered, that will be equal to ft into v. So ft will be m into kr is equal to m kr into v, that is ktr. So this will be m k square r square t. So m k square r square t. So option C is the correct answer. So here it is told that a stone tied to a spring of length L is wheeled in a vertical circle. So this a stone is wheeled in a vertical circle and this point is fixed. It is wheeled, so it is tied to a spring of length L in a vertical circle with the other end of the spring at the center. At a certain instant of time, the stone is at its lowest position. The stone is at its lowest position and has a speed u. It has speed u. The magnitude of change in velocity when it reaches a point, when it reaches a position where the string is horizontal is so when the spring, so it should be string actually. Here it is written spring, here it is written string. So it should be string, not spring. Okay. So when the string is horizontal, it- here the velocity is, let's say, v. So then it is along j cap. So the change in the velocity vector, that is equal to v j cap minus u I cap. So the magnitude of the change in velocity, that will be equal to square root of u square plus v square. So this has been asked. We have to find it. So now we can use the conservation of energy. So here the uh, kinetic energy is half mu square plus potential energy is, let's say, 0, and that will be equal to, here the potential energy is mgl and plus half m v square is the kinetic energy at this point. So then we can find v. So v square will be equal to u square minus 2gl. V square will be u square minus 2gl. So therefore, the magnitude of the change in velocity, that will be equal to u square plus u square minus 2gl. So this will be square root of 2u square minus 2gl. So this will be square root of 2 into u square minus gl. So therefore, the value of x will be 2. So option B is the correct answer. Then here it is told a ball is released from rest from the point P of a smooth semi-spherical vessel as shown in the figure. The ratio of the centripetal force and normal reaction on the ball at the point Q. The ratio of the centripetal force at the point Q and the normal reaction of the ball at the point Q is A. Okay. So the normal reaction force will act towards the center only, and centripetal force, that will also act towards the center. Here we have mg. So therefore, if this is angle alpha, angular, it is told that while angular position of point Q is alpha with respect to the point P. So this is angle alpha. So therefore, you can say that this angle is alpha. So this will be also alpha. This will be 90 minus alpha. This will be again alpha. So this will be mg cos alpha, and this will be mg sin alpha. This is alpha. This is 90 minus alpha. This is alpha. Okay. So therefore, which of the following graphs represent the correct relation in between A and alpha when ball goes from Q to R? So we can say n minus mg. This will be mg sine alpha. Okay, n minus mg sine alpha. That is the net force towards the center. That is equal to mv square by r. So that is equal to the centripetal force. So now the ratio of the centripetal force and the normal reaction on the ball at point Q. So this will be 1 minus mg sine alpha by n. So this ratio, they are calling it as A. Present the correct relation in between A and alpha. The ball goes from Q to R. So the normal reaction will also increase, and mg cos alpha, that is equal to uh, the tangential force, that is equal to m to the tangential acceleration. It is equal to m into dv by dt. So therefore, we can say that dv by dt, that will be equal to g cos alpha. And fc, that is equal to actually mv square by r. Mv square by r, the radius is constant. Mv square by r, that is equal to n minus mg cos alpha. No, mg sin alpha. Okay. So v equal to, I can say v will be equal to g cos alpha into t. Since why it is released from rest at the point P. Initial speed is 0. So therefore we can say m by r into this is v square, that is g cos alpha into t, g cos alpha into t whole square, that is equal to n minus mg sin alpha. So therefore n will be equal to m by r into g square cos square alpha into t plus mg sin alpha. Now we have to find the ratio of the centripetal force and the normal reaction. So centripetal force and the normal reaction Fc by n, that is equal to A, that is equal to 1 minus mg sin alpha divided by n. So this will be 1 minus mg sin alpha divided by This is m by r g square cos square alpha into t plus mg sine alpha. So m I can cancel out, and g also I can cancel out. 1g I can cancel. So this will be 1 minus sine alpha by g cos square alpha t square actually, g cos square alpha t square by r plus sine alpha. So if we divide by sine alpha, then a value we will get 1 minus 1 by g by r cos square alpha by sine alpha. So this is cos alpha into cos alpha by sine alpha. That is cos alpha into cot alpha. This is cos square alpha by sine alpha plus 1 into t square. Okay. So so here what will happen? Acceleration should be a function of alpha. The a should be here actually we can say one thing, that is fc that is equal to n minus mg sine alpha, and the tangential force that is mg cos alpha. And here ft I can say that is m into tangential acceleration, and tangential acceleration I can say it is omega d omega by d alpha, since why here alpha is the angle. Fc that is equal to m omega square r. So therefore we can say omega d omega by d alpha that is equal to g cos alpha. So therefore omega square by 2. So initially the speed was 0 only, so the angular speed was also 0 only. So this will be omega d omega that is equal to g cos alpha into d alpha. Now if you integrate it, then we will get omega square by 2 that is equal to integral cos alpha that is sine alpha. So that is g sine alpha 0 to alpha, and this will be from 0 to omega. But this is g sine alpha. So omega square that is equal to 2g sine alpha. So therefore n equals to mg sine alpha plus mr into omega square, which is 2g sine alpha. So that will be equal to mg sine alpha into, I can write 1 plus 2r. 1 plus 2r. So this is n. So we have to find fc by n that is equal to the value of a, which is the ratio of centripetal force and the normal reaction. So this will be a will be fc that is m omega square r, that is mr into omega square, that is 2g sine alpha, divided by n, that is mg sine alpha into 1 plus 2r. So mg sine alpha will cancel out. So this will come 2r by 1 plus 2r. So r is the radius. So this will be a constant. So it is independent of alpha. Independent of alpha. So therefore, it will be a straight line. So option C is the correct answer. Then it is told that a disk with a flat small bottom beaker placed on it at a distance r from its center, a disk with a flat small bottom beaker. So there is a disk placed on it at a distance r from its center. So here a small bottom beaker is kept at a distance r from its center, uh, is revolving about an axis passing through the center and perpendicular to its plane with an angular velocity omega. So this is the disk which is rotating with an angular velocity omega, and this is the small bottom beaker which is kept beaker which is kept at a distance r from its center, and the coefficient of static friction in between the bottom of the beaker and the surface of the disk is mu. So here the coefficient of friction is mu. The beaker will revolve with the disk if the beaker will revolve with the disk if okay. So here the static friction will provide the necessary centripetal force that is equal to m omega square r, omega square r, and the static friction that should be less than or equal to the maximum static friction, which is equal to mu mg. Here m is the mass of the beaker, suppose, so its weight will act, and this is the normal reaction. So we know that fs max, the maximum static friction or the limiting friction, that is equal to mu s into n, or mu times n, mu n. Okay. So here n will be equal to mg, so it will be mu mg. So therefore fs, that is equal to m omega square r, that should be less than or equal to mu mg. Therefore m will cancel. So therefore r should be less than or equal to mu g by omega square, or should be less than or equal to mu g by omega square. So option B is the correct answer. Then here it is told, for a particle in uniform circular motion, the acceleration a at any point p r comma theta on the circular path of radius r is, the acceleration a at any point, the acceleration a at any point p r comma theta on the circular path of radius r is, a particle is performing uniform circular motion. Okay. So this is the x-axis. Theta is measured with respect to the x-axis. This is y-axis. So this is the angle theta. The particle is at point P r comma theta. So OP is the radius r. So then the acceleration will be acting towards the center. Acceleration will be acting towards the center. Okay, then it is moving with a velocity v. So therefore acceleration will be equal to, so therefore the position vector of the particle P is r x coordinate is x coordinate, that is equal to r cos theta, y coordinate will be r sin theta. So this is r into cos theta I cap plus sin theta j cap. Then dr by dt, that will be equal to v, and its magnitude should be constant. So this is equal to r sin theta, r into this is minus sine theta I cap plus cos theta j cap into d theta by dt, which is omega. So omega is equal to v by r, we can write. So omega is v by r. So v vector I can tell that is v into minus sine theta I cap plus cos theta j cap. And then acceleration will be equal to dv by dt. So this will be v into minus cos theta I cap minus sine theta j cap into d omega by into d theta by dt, that is omega. Omega is again v by r. So this will be equal to v square by r into minus cos theta I cap and minus v square by r sine theta j cap. So option C is the correct answer. Or simply we can do like this also. Acceleration will be equal to v square by r into minus r cap. So here, as you can see, r cap is cos theta I cap plus sine theta j cap. So minus r cap will be negative of this. So this will be the required acceleration. And here it is told a stone of mass m tied to a string is being whirled in a vertical circle with a uniform speed. A stone of mass m um, tied to a string. Stone of mass m tied to a string is being whirled in a vertical circle with a uniform speed. Uniform speed is, let's say, u. The tension in the string is. So let's say at this point, the tension is T. And we can say that T minus mg, that will be equal to m u square by L. Let's say L is the length of the string. So this will happen at the lowermost point. At the lowermost point, let's call this as point A. So TA will be equal to mg plus mu square by L. And when it will reach point B, then this will be the tension, that is TB, suppose. So this will be mg, this will be u. So here we can say that TB, that will be equal to mu square by L. So therefore, obviously, we can say that TB is obviously less than TA. And when it will reach point C, which is the uppermost point, then U will be like this, and then this will be TC. And here mg also will be acting. So here we can say TC plus mg, that will be equal to mu square by L. So at all points, we are saying that the speed will be same only u, since it is told that it is whirled in a vertical circle with a uniform speed. So therefore, TC here will be mu square by L minus mg. So obviously, TC will be even lesser. TC will be lesser than TB also. So TC less than TB less than TS. So it means the minimum tension will be at the highest point of the circular path. Minimum tension is at the highest point of the circular path. So option B is the correct answer. And here it is told a flywheel is accelerated uniformly from rest. A flywheel is accelerated uniformly from rest and rotates through 5 radian in the first second. A flywheel that is being rotated from rest. So the initial angular velocity is 0 and rotates to 5 radian in the first second. So it means we can say omega equals to omega naught plus alpha t. So it is accelerated uniformly. So it means alpha is constant. Alpha is the angular acceleration that is constant. So we can say omega equal to omega naught plus alpha t. So therefore, in t equal to 1 second, it rotates through 5 radian. So therefore we can say that theta will be equals to theta naught plus omega naught t plus half alpha t square. So now the angle rotated, that is theta minus theta naught, that is equal to omega naught t, that is 0, so half alpha t square. So in t equal to 1 second, theta minus theta naught, that will be equal to 5 radian. That has been told. So therefore we can say that 5 radian, that is equal to half into alpha into t square, which is 1 square. So therefore alpha will be equal to 10 radian per second square. So this is the angular acceleration. Then it is told the angle rotated by the flywheel in the next second. So therefore uh, we say that angle rotated in the next second, let's call this as theta 2, that will be equal to theta in the second actually. So that will be equal to theta till at t till t equal to 2 seconds minus theta till t equal to 1 seconds. So this will be equal to theta naught plus half into alpha into t square. T square, so 2 square minus this will be theta naught plus alpha, since omega naught is 0 only, since it starts from rest, theta naught plus half alpha into 1 square. So this is 5. This is 2 twos are 4. So this is 20 minus 5. Theta naught will cancel out. That is 15 radian. So it will rotate by an angle 15 radian in the next second. So option B is the correct answer. And here it is told a boy ties a stone of mass 100 gram to the end of a 2-meter long string and whirls it around in a horizontal plane. So the length of the string is L. L is equal to 2 meter, and the mass of the stone, that is was 0.1 kg. It is whirled in a horizontal plane. It is whirled in a horizontal plane. The string can withstand a maximum tension. The maximum tension is 80 Newton. Maximum if the maximum speed with which the stone can revolve is k by pi revolution per minute, then the value of k is. So then it is told the maximum speed with which the stone can revolve, that is k by pi revolutions per minute. Then the value of k will be how much, that has been asked. So here we can say that T will provide the necessary centripetal force, that is mv square by L. So therefore V square will be equal to TL by M. So therefore V maximum square, that will be equal to T max into L by M. So T max that will be equal to 80 into L, length of the string, that is length of the string, that will be equal to 2 meter divided by the mass, that is 0.1. So this will be equal to 2 8 is 1600. So therefore V max, that will be equal to 40 meter per second. Now 40 meter per second we have to find in revolution per minute. Now V is equal to R omega. V max will be equal to R into R. R means L. L into omega max. So omega max, that will be equal to V max by L. So 40 by length, that is 2 meters. So it is 20 radian per second. 20 radian per second. So it means therefore in 1 second it makes 20 it it rotates by an angle. It rotates by angle 20 radian. In 1 second, it rotates 20 radian. So therefore, in 60 seconds, it will rotate. It will rotate by angle 20 into 60 radian. It means it will be 20 into 60. So now 2 pi radian, that we know, that is equal to 1 revolution. So therefore 1 radian we can say that is 1 by 2 pi revolution. So therefore this divided by 2 pi, that will give us this many revolutions. So therefore the maximum angular speed of rotation, maximum angular speed of rotation, that will be equal to 20 into 60 by 2 pi revolutions per minute, and that is equal to k by pi revolution per minute. Then we have to find the value of k. So this will be 210. So this is 600 by pi, that is equal to k by pi. So therefore the value of k will be equal to 600. So the value of k will be equal to 600. So option C is the correct answer. And here it is told a person starts his journey from center O of the park and comes back to the same position following path OP. Okay, starts from center O, starts from here, and then it goes along this path, which is OPQO, as shown in the figure. The radius of the path taken by the person is 200 meters. So the radius is 200 meter, and he takes 3 minutes 58 seconds to complete his journey. Then the average speed of the person is, so 3 minute. So we have to find the average speed in meter per second. So now 3 minute 58 second means it is 3 into 60 plus 58 seconds. So this will be 3 6 18, 180 plus 58, that is equal to 238. Okay, 8 plus 5, that is 13. Okay, so 238 seconds. And the length of the path, the length of the path that is taken by the person, or I can tell the distance covered, the distance covered by the person, that will be equal to the length o, OQ plus OP plus PQ. OP plus PQ plus OQ. Right. So OQ length will be R, OP length also will be R, plus PQ length, that will be equal to, it is 1/4 circle, so it is 1 by 4 into 2 pi R. So this is pi R by 2. So this is 2R plus pi R by 2. And pi we have to take it as 3.14. So this will be 2 plus pi by 2, that is 3.14 by 2 into R. R is equal to 200 meters. So this will be equal to 400 meter plus this is 200. So 100 into this, that is 314 meters. So this will be equal to 714 meters. So now therefore the average speed, that will be equal to the total distance traveled, the total distance traveled divided by the total time taken. Total time taken. So it is 714 meter divided by the total time taken, that is 238 seconds. This will be 2, we can cancel. 2 ones are 2, 2 to the 4, 2 ones are 2, 2 ones are 2, 9s are 18, and then 2, 3 are 6, 2 5s are 10, 2 7s are 14. So 119 into 3 if you do, then we will get 3 9s are 27, 3 ones are 3, 5, 3 ones are 3. So 119 into 3. So this is 3 meter per second. So 3 meter per second is the average speed of the person. So hope all of you have understood the solutions of all these questions in the second part of this chapter on circular motion. So please install our Sapience education application also, where we shall upload some more important questions based on the previous year JEE Mains exam on every chapter of physics. And still, any doubts if you have in any of the steps of these solutions, then please write us in the comments section. So thank you everyone. Bye.